All right, so this is 1-2 notes. So today we're going to talk about the different definitions for numbers. So you have this definition right here, right? So it says the real numbers, rational, irrational, integers, whole numbers, natural numbers. So real numbers are basically any number that you can think of, all right? It can be pi, it can be 5, it can be 10,000, it can be negative 1/2, it can be anything, all right? The only thing that it cannot be is a imaginary number. You guys know what an imaginary number is? No? It's when you divide by a negative, sorry, not divide, but you take the square root of a negative number, all right? Which you're not really going to see in this class very much, maybe towards the end. Okay, so you don't have to really worry about imaginary numbers, not that you would worry about it anyway, all right? So every number that's going to be on this homework will be a real number, all right? So that's going to apply to everything. Now the rational numbers is a number that you can actually write as a fraction, all right? But it can only be written as a fraction. So for example, you guys have your calculator, right? So let me ask you a question here. So obviously, if you're not sure, if you're looking at this and you're wondering, okay, is this a rational number, yes or no? It might be kind of hard. It's kind of hard for me to even be able to tell just by looking at it. So what you can do in your calculator is type that number in if you haven't. So type it in. And then press the button math and then press enter. See how it says fraction right here? So press math and enter twice. All right, and it tells you that that decimal point is 5/8. All right, so 5/8 is a rational number. Okay. Now, an irrational number is a number that you cannot set up as a fraction at all. All right, so the most famous example would be pi. All right, pi is the most famous irrational number. It's 3.14, and I don't really know what else after that thing is. I heard you kind of mumbling. No? Do you know what it is? Okay. I think it's 141621, but I'm not sure. All right, so if you're listening to this on video, don't bash me like you suck on comments. I do suck, but keep it to yourself. Let me give you another irrational number that happens all the time. Okay, so what is the square root of 4? Square root of 4? Simple question. 2, right? Yeah. No, don't be scared. It's 2, right? So you can think of that, right? But if I ask you, what is the square root of 2? And don't know. It's some kind of decimal point, right? We can agree on that. So if I type in the square root of 2 and I press enter, it gives me this number. Now, this square root of 2 is an irrational number, but sometimes it's hard to tell. But with this calculator, you can actually be able to tell really quick. If you're able to turn this decimal point into a fraction, then it's a rational. Otherwise, it's irrational. So if I press math and I press enter, enter, it should give me a fraction, but it doesn't because it can't. This cannot be put as a fraction. Right, so that's an example of something that's irrational. Integers, as you can tell here, there are numbers. They can be like, it cannot be a 1.5 or a 1.6. They have to be whole numbers, if you will. Okay, but they include the negatives and 0. All right, and whole numbers, so that's that. I was kind of looking for another word than whole because now you have whole numbers. Whole numbers are like this numbers, except you don't have any negative numbers. So right here you have no negative numbers. And this is not a hashtag, this is a number sign, all right? So no negative numbers. All right, and then natural, what's the difference between the whole numbers and the natural numbers? There's no 0, correct. So this one has no 0 and no negative numbers, right? Are we understanding that? Okay, so now I'm going to show you this real quick. I don't necessarily need you to write it. I just want to do it all over again. This is how that works basically. All right, so pretend that this whole square right here, the whole square is all the real numbers. Irrational numbers are over here. And everything else, if you have, for example, this is a natural number here all the way on the inside. But if you have a natural number, then that natural number is also a whole number, which is also an integer, which is also a rational number. Okay, so notice that basically I'm saying that this is part of everything, right? And if you're here in this circle, then you're also part of this bigger circle, and so on. All right, so let me give you an example to make that easier. All right, let's look at number 1. All right, number 1, all of these are going to be real numbers. So you can even write an R there already on all of them because they're all real numbers, okay? Now the next question is this a rational number? Actually, let's go backwards. I think it's easier to go backwards. So if you look at here, right, is 6 over 7 a natural number? It's not. It has to be like, I hate to say it because I can't find another word for it, dang it. It has to be kind of like a whole number, right? If it's a fraction, it doesn't work. So it's not a natural number, and if it's not that, it's not a whole number, it's not an integer. So really the only thing that it could be is either irrational or rational. So which one is it? Is it irrational or rational? It's irrational because it's a fraction. See, the word ratio kind of sounds like a fraction, right? So this is real and this is also rational. So we have R and Q. Now in the next one, you have to use maybe a little bit of math. If you have negative square root of 81, what's the square root of 81? Right. But with this negative, it's going to make that a negative 9, all right? Now let's look from the bottom up. Is negative 9 a natural number? No. Is it a whole number? Is it an integer? So it's an integer. So we have z. And now every integer is going to be a rational number. Okay, so that one kind of gives me that automatically. And this also has to be a real number. Right, so every integer is a rational number. Make sense? Right, and if that doesn't make sense, think about this number, negative 9, right? Could I rewrite this as negative 18 over 2? What's negative 18 over 2? It's negative 9, right? So I can write that as a fraction, but I can actually write that better as just a, what do you call it? As a number, right? It's still rational. I wrote it as a fraction. So 0 is an interesting one. Let's go from the bottom. Is it a natural number? Is it a whole number? Is it an integer? And now this one, I'm going to go ahead and tell you this, also a rational. Sorry, I meant to write a z here. So it's a z. And then what else do we got? Rational and then real. Okay. And then now, integer. Yeah. Yeah, that's what confuses me. I accidentally wrote an I instead of a Z here, but that's because you have too many things starting with an I or an R. Okay. All right, finally on number 4, you got 192.0005, 0005, okay. And now the question is this a natural number? And that might be hard for you to tell, but if it's point something something, then it's not a natural, it's not a whole number, it's not an integer. Neither one of those, okay? If it was just 192, then it would be those 3. Okay. Now the question is this rational or irrational? And if you're not sure, if you're like, well, I don't know, okay? Very quickly, type this in your calculator. And then you press math, enter, and it turns it into a horrific fraction. But my point is that it's a fraction, right? So it's rational. So this would be rational. And this is also real. All of these are real. Okay? So I'm not going to do all of these because it can get, I'm not going to do, 20 examples? It hurts my soul to even talk about it, okay? So let's not do that. I will just talk about very quickly about 11. Do you guys recognize that little line on top of that number? What does that mean? Right, it's repeating. That 17 repeats itself over and over and over. And when that happens, that's also a rational number. Okay, so a number that repeats itself that's very famous, for example, is 1 divided by 3. That's 0.3333 repeating. Okay? So this is obviously a rational number. This is also a rational number. All right? So remember what we talked about. It's not a natural, it's not a whole number, it's not an integer. Because they have to be whole numbers. They have to be a solid whole number. Okay? So the only thing it can be is going to be rational and are also a real number. Now the square root of 42, type that in your calculator. Square root of 42. If you cannot think of the square root of 42, which I can't, all right, but what is the square root of 42? It just goes on, right? Is it 62? No, 42. Okay. So you got that number. Now that kind of tells me it's irrational, but if you're not sure, you can still press the button math and then press enter twice. You cannot put it into a fraction, so this is an irrational number. So we have a rational, and this is also a real number. Okay? All right, moving on to the back here. That's enough of that. Now I'm going to be real honest with you. I don't care if you know what the property is called. I really don't. I really don't care if you know what it's called, as long as you know how to use it, especially the distributive property, which you should be very familiar with. All that says is if you have a number on the outside, and in parentheses you have a plus. Does that scare you to see that many letters? You get scared? You like dream about this? All right, just kidding. All right, you have A times B and A times C, so that's what you have here. Okay? So that's all I really want you to know about that. I just want to be able, I want you to be able to use them. I don't care if you know what they're called. Anyway, so to simplify, it's actually very simple, something you've done before in the past. All you have to do in the first one, for example, is distribute. So we got A times 3A and A times B, and then we got 4 times 2B and 4 times negative A. All right, so this would be 24A minus 8B plus 8B minus 4A. Okay? Now at that point, all right, don't be confused. There's a few kids that were kind of got messed up on the homework. You're just adding like terms. So I have to add everything that's alike. All right, so notice that this and that, they're like terms, so I can add those two together. So 24A minus 4A is 20A. And then I have negative 8B plus 8B. What does that equal to? 0. Maybe 0B if you want to look at it like that, right? But it's 0, right? So I'm not even going to write it. I'm just going to leave it like that, 20A. Right, and finally, well, I'm going to do a couple here. This one's easy. You just have to add the like terms. That's a like term. This is a like term. So that's 51R plus 18T minus 5T. What is that? 13T. And don't do anything else with that, okay? You cannot add those two together because they're not alike. They're different terms, okay? It's like trying to add apples and oranges. You can't, all right? They're not the same. All right, finally on number 3, let's do a little bit of fractions here. If you multiply something times 1/5, is the same thing as dividing by 5. It's exactly the same thing, all right? So if I divide 4 by 5, I get 4/5 J. If I divide this by 5, I get 2 over 5K minus 6 over 5J plus 3 over 5K. All right, now at that point, I'm going to add like terms. So let's try to do it without a calculator. All right. So notice that on here I have, these are my J terms. Right. Now remember, to add fractions, you have to have a common denominator. Do I have a common denominator in these two? Yes. I do. So all I really have to do is add the 4 and the negative 6. So 4 minus 6 is negative 2. Negative 2/5 J. And then now I have 2/5 K plus 3/5 K. I have a common denominator. I can just add the top. So what is that? It's just K, right? But let me just write it as 5 over 5. Don't want to lose anybody here. And 5 over 5, what's 5 divided by 5? 1, all right? So from now on, I'm not going to use the word canceling because that gets really confusing for a lot of you, right? When you're quote-unquote canceling, when you're dividing, you're actually just getting a 1 back. 5 divided by 5 is 1, okay? We're just going to go ahead and stop there with the notes. Let's go ahead and look at the homework real quick. Let me tell you what to do, what not to do. We're not going to do all of it, okay? Let's see. Okay. Let's do, and I already wrote it here. Let's do all the evens one, all the evens ones, all the even ones. All right, let's try to do all the evens, but we're not going to do 7 through 18. All right, 7 through 18, no, but all evens. You with me? Okay, now let me turn this around because there's a lot of problems in the back too. All right, turn this around and, whoops, I only did a couple, but all evens except I do not want 9 through 22. Cancel those. So the homework shouldn't be that long for you. I'm trying to shorten your homework so you can get it done. Okay? And that's it. Any questions? And there's a couple for you here in case somebody asked me about this, so I did them. So there you go. So all evens, okay? Except for those ones that I told you about.